Turkey, Haiti, Indonesia, Japan, New Zealand, Chile, California, even New York City and Washington, D.C. These are just a few places in the world that have recently been hit by an earthquake or tsunami. Earthquakes and tsunamis have been occurring since the dawn of time, and they will continue as long as the Earth rotates around the Sun. Humans may never be able to prevent them, but we can definitely prepare to survive them better. One organization is dedicated to limiting the enormous amount of physical destruction, economic disruption, and human carnage that they leave in their aftermath. The George E. Brown Jr. Network for Earthquake Engineering Simulation, or NEES, is pioneering the mission to reduce the impact of earthquakes and tsunamis on society through research, engineering, science, and education.
Known for its cutting-edge research at the laboratories, NEES is also helping the earthquake engineering community to become more collaborative and interconnected, not only in the United States, but globally.
Earthquakes are the result of a sudden release of energy in the Earth's crust that creates seismic waves. They are caused by the rupture of geological faults. A tsunami can be generated by underwater volcanoes, an underwater landslide, or when an earthquake abruptly deforms the sea floor and vertically displaces the water above it. Both earthquakes and tsunamis can cause a tremendous amount of damage to infrastructures. Buildings can collapse. Foundations can crack. Roads, bridges, pipes, and other infrastructure can also be destroyed or compromised, not to mention the displacement of people from their homes and cities. NEES is dedicated to providing engineers, architects, and other practitioners with the critical research they need to design structures to perform well during earthquakes.
By coordinating the experimental research in earthquake engineering at different labs in the United States, we get information that we otherwise don't have. This type of information is necessary for us when we try to design new and modern structures.
NEES facilitates research at 14 testing locations in conjunction with various major universities across the nation, with headquarters of operations at Purdue University. The facilities are equipped with major research assets that vary from an enormous tsunami wave basin to a shake table that simulates the ground motion during an earthquake and can put a bridge support, a full-scale building, or even a wind turbine through performance tests. The results indicate improvements that can be made to building codes and construction techniques so that the infrastructures we rely on can undergo an earthquake or tsunami and remain functional. This research is then shared with engineers, researchers, and practitioners around the world through the NEES Hub. The NEES Hub applies Hub Zero technology, which is a new way for scientists and engineers to publish and share information. Researchers are able to run models using a simple internet interface that will connect to the supercomputing resources on the NSF's XSEED and the National Open Science Grid OSG. This allows for quick processing of simulation. The NEES Hub brings world-class research to any place in the world that has broadband internet access.
All of this combination of experimental facilities as well as cyber infrastructure makes NEES an invaluable national resource, which has the single purpose of accelerating improvements in seismic design and performance by serving as a laboratory without walls for researchers, educators.
Finding the projects on the NEES Hub is pretty easy, and you can find it and also several data that they have from different tests. You can have that and you can download that and you can use in your analysis. So there is no need to chase the data.
Another important component in the NEES mission is education and outreach. It implements programs to engage our youth, students, practitioners, and even the general public. Currently, many experiments funded by the National Science Foundation, other federal agencies, and industries in NEES are being conducted by researchers from the U.S. and abroad, showing the impact of earthquakes and how to minimize the damage. One experiment recently showed how the traditional orthogonal design of placing shear studs allows slab cracking in concrete and could lead to premature failure. Research showed that by using a radial layout of the studs, the concrete could withstand far more shaking without cracking, and because of this, building codes are being changed to reflect those results.
There are many formulas in the building code. Some of them are decades old. Some of them are a few years old. Many of them are based on analytical research. Some of them are based on experimental research. When we try to do something new, those formulas might not necessarily apply. We need experimentations such as the ones that NEES coordinates in order to see if the formulas that we are using are applicable to the new situation or not.
At the NEES Tsunami Wave Basin at Oregon State University, they are simulating landslide-generated tsunamis and accurately measuring the characteristics of the landslide and the waves. At the facility at the University of California in San Diego, they have tested a full-scale reinforced masonry shear wall structure that you might find in a typical apartment, school, or hotel. This experiment on the world's largest shake table subjected the structure to a magnitude 7.5 earthquake. In Los Angeles, researchers from UCLA placed sensors throughout the landmark Los Angeles Airport theme building after it was retrofit to withstand the big one. Using a portable mass shaker called the Mighty Mouse Shaker, they excited the building and confirmed the retrofit design and analysis assumptions. Building earthquake and tsunami-ready structures requires an enormous amount of testing, research, simulation, and experimentation. By proactively creating and simulating the stress, shaking, and deformation inflicted on a structure during these natural disasters, we can construct an infrastructure that will remain standing and functional when the big one hits.
We envision NEES becoming an active and engaged collaboratory where researchers and educators share new knowledge, contribute data and tools, provide new design techniques, and most important of all, through the educational activities of NEES, we help educate the next generation of earthquake engineers and researchers, the leaders of tomorrow.
Every day, NEES continues to accelerate improvements in seismic design and performance by serving as an indispensable collaboratory for discovery and innovation. The pioneers at the Network for Earthquake Engineering Simulation are helping to make it possible for our structures to stand up to earthquakes and tsunamis, and this can help prevent these natural disasters from becoming heartbreaking tragedies. For more information about the George E. Brown Jr. Network for Earthquake Engineering Simulation, log on to nees.org.